Hello everyone, I am Professor Tiwari. Welcome back to the second video in our ACT revision series. In this session, we will do a quick and focused review of core trigonometry concepts that frequently show up in ACT, especially in questions related to triangles and geometry. We will cover trig ratios, spatial triangles, identities, and some quick strategies to help you solve these questions with speed and confidence. Let us start with some trig ratios for a right triangle as shown in figure 1 here. In this triangle, angle theta is one of the acute angles. The opposite side is directly across from theta, opposite side. The adjacent side is next to theta, this is the adjacent side, and the hypotenuse is the longest side opposite to the right angle. This is the right angle and hypotenuse is opposite to this 90-degree angle. So, now some definitions, the ratios. Sine of theta is the ratio of opposite and hypotenuse. So, opposite by hypotenuse is called sine theta. So, opposite is shown here and hypotenuse is here. So, if you take the ratio of opposite and hypotenuse, you will get the sine of theta. Cosine of theta is the adjacent, this one, over hypotenuse. So, if you take the ratio of adjacent and hypotenuse, you get the value of cosine theta. And tangent of theta, tan theta, is the ratio of opposite and adjacent. Opposite by adjacent is called tan theta. These are the foundation of ACT trigonometry, and it is essential to identify the sides correctly based on the given angle. So, it is very important to understand how to correctly identify opposite, adjacent and hypotenuse relative to a given angle. As soon as you see this angle theta, in your mind you should immediately visualize that which one is adjacent, which one is opposite and which one is hypotenuse, because the question which they will ask will be based on this fact. Now, let us look at two spatial right triangles commonly tested on the ACT. Those are 45-45-90 triangle shown in figure 2 and 30-60-90 triangle shown in figure 3. Starting with figure 2, the 45-45-90 triangle, you can see the side ratio is 1 to 1 to root 2. And then second important observation, that the legs are equal, these two legs are equal, and the hypotenuse is under root 2 times the leg. Hypotenuse is under root 2 times the leg. Now, look at the figure 3, the 30-60-90 triangle. In this case, the side opposite to 30 degree is the shortest and is labeled as x. The side opposite to 60 degrees is x multiplied by square root of 3 and the hypotenuse is 2x. So, side ratio 1 under root 3 2, 1 under root 3 2, opposite to 30 x, opposite to 60 x under root 3 and hypotenuse is 2x. These triangles often appear on the ACT without angle labels. So, recognizing these side ratios quickly can save time and help you solve problems faster. Here are some quick but very powerful trig identities to remember for doing well in ACT. The first one is Pythagorean identity, which says sin square theta plus cosine square theta equal to 1. So, this identity holds true for any angle. Irrespective of the value of theta, this will always be true. Theta may be 10, 20, 90, 80, any number. So, this sin square theta plus cosine square theta equal to 1 will be true for any angle. Second identity, which is important especially for ACT test, is tan theta equal to sin theta by cosine theta. And again, these are the identities, so are true for any value of theta. So, this is also very often some of in questions you may have to use this second identity. Now, we will move to inverse trig, and we will start with some example. For example, if they give the sine of theta is 0.5, then if you have to find the value of theta, you will write theta equal to sine inverse 0.5. This gives us the angle whose value is 0.5. To be able to solve this kind of questions, it is important that you memorize the exact values of 0, 30, 45, 60 and 90 from a table which will be next slide. And for other angles, you should be very good in using your calculator, and especially in degree mode. So, do some practice so that you can quickly use your calculator and can get the value of theta by using that in a degree mode. This is a must know reference table for standard angles for the ACT exam. For each of these angles 0, 30, 45, 60 and 90, you should be able to recall the exact values of sine, cosine and tangent without a calculator. So, you should memorize this thing by heart. At 0 degree, the sine is 0, cosine is 1 and tangent is 0. At 30 degree, sine is 1/2, cosine is square root 3 over 2 and tangent is 1 over square root 3, or you can also say square root of 3 over 3. At 45, both sine and cosine are root 2 over 2 and tangent is exactly 1. At 60 degree, sine becomes root 3 over 2, cosine is 1/2 and tangent is root 3. And at 90, sine is 1, cosine is 0 and tangent is undefined, because you can't divide any number by 0. So, practice recalling this table quickly. It can save valuable time during the test. Now, we discuss laws of general triangles. Figure 4 here shows a general triangle, not necessarily a right triangle. It may be right triangle or may not. In such cases, we use the law of sines and law of cosines. There are two laws which are used in the case of general triangles. The law of sine, which is shown here, relates the ratio of side length to the sine of its opposite angle. That means sine of A over A length here equal to sine of B over B equal to sine over C over C. So, this will be true for any triangle, whether rectangle triangle or any equilateral triangle or anything, any kind of triangle will obey law of sines. Next is the law of cosines, which helps when we know two sides and the included angle. So, it is very important to emphasize on included angle. Okay, so, let us say if you know A and B and your aim is to find the value of C. Then in this case, you know the value of A and B, and your included angle is C. So, law of cosine says C square equal to A square plus B square minus 2AB cosine of angle C. Okay, this cosine of angle C. So, now if it is a rectangle where C is 90, then you know this cosine term will become 0, and you will end up with the relation C equal to A square plus B square, which is for normal 90-degree rectangle triangle. But because in this case the angle C can be any arbitrary angle, so if you use the law of cosine, you can find the value of C. So, it is very important to use the right angle. This is the included angle. Okay? And suppose they give you the sides B and C and ask you to find the value of A, then your included angle is this one. So, you have to properly choose which angle to be used. So, normally these are not very common on the ACT, these laws for general triangles. Many times they do not ask many questions, but it is a good idea to know them, and so in case any question is asked, you will be able to solve that without much problem. Here are some final thoughts and key takeaways. First, combine formula memorization with logical reasoning. Practice for both conceptual understanding and speed. Memorize basic trig ratios and identities. Recognize spatial triangles and standard angle values. And then apply trigonometry in geometric problem solving. And most important, be comfortable with inverse functions and calculator use. I hope this quick review helped you refresh the basic concept that you need for preparing for the ACT exam. We will keep building on this more in coming session. Till then, keep practicing the questions, and if you have not subscribed yet, please go ahead and do that now. Thanks for watching, and I will see you in the next one.